Cool. Yeah, hey everyone. So I am going to talk about web performance and different ways to kind of measure web performance. But before I do that, I just want to give a brief introduction to kind of page speed. So this is an example of a website, if it eventually loads. As you open a page, gradually some content starts showing up, and you kind of want to optimize the page so it kind of loads as quickly as possible. And we can also look at the film strip, and then we can see like not all page content kind of shows up at the same time. So there is like the film strip, and you can see after about 2.5 seconds, some content starts showing up. And there's one metric called the first contentful page, which measures like how long that takes. And then a bit later on, we have this kind of background image, which is like the largest contentful page, which is the single largest content paint element that appears on the page. So why do different bits of content kind of show up at different points in time? So basically, when you open the website, it loads a whole bunch of resources. And it starts with like the HTML document. And then in the HTML document, you are referencing like CSS files and scripts and images and all that kind of stuff. And that is kind of why it's very waterfall, because the first request kind of triggers a whole bunch of additional requests to happen later on. So most important here are these kind of render blocking requests. So those basically prevent any content from showing up on the page. And here, I think this design system CSS file, that's the last render blocking file on the page. And you can see as soon as that request has finished, that's kind of when in the film strip we can see that the user actually can start seeing content here. We can also look at individual requests and ask, like, why do they take as long as they do? And basically, each request, there are two components. One is you need a server connection, so you can make the request, and then you make the actual HTTP resource request after that. And to establish a connection, you need to do three things. You need to look up the IP address of a DNS. You need to establish a reliable TCP connection, and then you need to secure SSL connection. And each one takes one round trip on the network. So especially if you're on a high latency connection, network connection, the actual HTTP or server connection can take quite a bit of time. And then, once that's done, you can actually make the request, and then you need to download the resource. And obviously, depending on how large the resource is and how much bandwidth you have, that's going to take less or more time. And the last thing I want to look at is request priorities. Ideally, the browser kind of knows, OK, this image is like the big hero image at the top of the page. And then there's also like a little social media icon in the footer, and we don't really need to care about the social media icon so much. So hopefully, it looks something like this in the waterfall view. You know that one image is high priority, and then all the data that the server is kind of sending over arrives for that piece of for that image or for that resource, and then after that, the lower priority resources start loading. Sometimes the server kind of still does messes up a bit and kind of intersperses important, unimportant data because some content delivery networks or servers don't support it properly. But yeah, hopefully you kind of load the most important resources early on so that the important page content kind of starts showing up as quickly as possible. So yeah, having kind of said that and talked about what is actually the technical factors that impact how fast the page loads, let's talk about different ways to collect this performance data. Fundamentally, there are two key approaches. One is you can run synthetic tests. So this is basically one in-depth test that you can run on your computer or in a server environment, and it is kind of run with a certain specific set of test conditions. And then you get a really detailed report. You can see the film strip view. You can see specific recommendations. You can see all the response bodies and all that kind of stuff. So that is one way to collect performance data. The other one is real user monitoring. So you kind of actually collect the data on the end user device. And rather than getting one super in-depth experience, you get this distribution of visitor experience. So depending on what content people are looking at, how fast their network is, and what the device is, that is going to impact the performance that they have when loading the page. So if you use PageBear Insights, probably the most widely used performance tool, you can see that they also have that. They have the real user the data at the top, and that comes from something called the Chrome User Experience Report. So basically, certain Chrome users are opted into analytics reporting. And then if a URL gets enough traffic, Google kind of aggregates and anonymizes that data, and you can actually look up how fast it is for real users, even if it's not your own website. And then below that is a Lighthouse report, which, it's a synthetic test, and that has the specific technical audits and recommendations that you don't have in the real user data. I'm going to focus on synthetic tests in this talk. And yeah, the important thing with synthetic tests is that you have a certain fixed test conditions. So this is a Lighthouse default configuration for mobile, and it's 150 milliseconds of network round-trip time and 1.6 megabits per second of bandwidth. So if you want to run a performance test, typically you might be like on your home Wi-Fi, or you might run the test in a server environment or in your office. So you have a pretty fast network. But so maybe a user is on like a train to Bristol, and like they are using a train Wi-Fi. You can see it's not really as fast as what you might have at home. So when you run a synthetic test, generally what you want to do is you want to throttle the network in some way so that somebody who is on a mobile network or train Wi-Fi can actually use your website. And what I want to talk about is like there are many different kind of approaches to do this. The three I'm going to talk about are packet level throttling, which is kind of what most of the kind of advanced performance tools use. There's something the Lighthouse uses by default, which is called simulated throttling. And then DevTools also has its own special type of throttling the network. And importantly, even if you test the same page with the same latency and bandwidth settings, you might still end up with different performance metrics just because of how the throttling is actually implemented. So packet level throttling, it works by basically like running something in your kind of network stack on the operating system and holding back each packet to kind of simulate latency and bandwidth. So this is kind of like the most reliable way to do it, because like if you look at request and it establishes a connection, or like it has any sort of exchange of data with the network, that is just simply slowed down by the computer when the data arrives. So that's kind of what DebugBear does. That's kind of what by-page test does. Or if you use something like the network link conditioner on Mac or iOS, you can also kind of actually apply the kind of packet level throttling. So the problem with that is it's kind of annoying to use because it applies to your whole computer because it's kind of in the network stack. So while DevTools, for example, you can just throttle one tab and like it doesn't break the rest of your computer, packet level throttling is not like that because it kind of integrates directly with the operating system. And again, because it integrates with the operating system, you can need admin rights. So it makes it a lot more annoying to kind of actually use on your own computer. So that's kind of why there are some of these alternative approaches. For example, simulated throttling, which is what Lighthouse does by default. So this is PageSpeed Insights results. And basically, the way that simulated throttling works is it kind of actually collects the initial measurements on a fast connection, and then runs a simulation and says, well, how fast might this page actually be otherwise? And here you can see we have like a measurement. There's like 3.4 seconds for the LCP. And then the actual reported LCP after the simulation on a slower connection is 21 seconds. So how does this work? Basically, you kind of can construct this kind of graph of like what has to happen before the LCP or another metric happens. So for example, here we have, let's say like a very simple example. We just load an HTML file, and then we load some CSS, and the page renders. And we know that takes 1.2 seconds. So what Lighthouse does is basically say, OK, let's add a bit of latency to each of these steps and kind of say, well, this request doesn't take 1 second, it takes 2 seconds. And does that based on this whole kind of graph, dependency graph that it's kind of built up, and says, OK, I think actually on a slower device, it would take 3.4 seconds to load this page. So yeah, this Lighthouse has its dependency graph, and it basically internally re-implements a lot of kind of network functionality, like the kind of TCP connection, and then just adds a bunch of latency on top of that. So I showed you a really simple example with just 2 requests, but like a lot of pages, they actually have hundreds of requests as they're loading. So that kind of makes it really complex. So how does Lighthouse actually know what content depends on what requests? And the answer to that, it doesn't really. So it's kind of unsure. So it basically says, well, maybe it's not that many, but it's like an optimistic estimate. Or maybe like there's loads of things that kind of load early on that are actually absolutely necessary for the large contentful paint to happen. So what it does, it has a pessimistic estimate, and an optimistic estimate. And then it just takes the average of those two. And that's kind of what shows up. Yeah, so this is easier to run. You don't need to affect your whole computer with it. And also, especially for PageSpeed Insights, like how a lot of people kind of want to run the test there, and their page takes like 40 seconds to load, but you don't want the whole test to like take over like a minute to run, because people are going to get bored. They're going to do something other than PageSpeed. So one advantage of simulated throttling is you can just like provide a really quick result, but it does come at the cost of like certain accuracy. So for example, in certain situations, you might apply an optimization to make your website faster, but then Lighthouse is going to say, well, actually, that made your website slower, when that's not really true. And you also get like somewhat weird situations like this one here, where on a fast connection, the page loaded in 3.1 seconds, But then Lighthouse is saying, well, if the connection had been slower, I think it would have been a second faster, which doesn't really make a lot of sense that way. And yeah, finally we have DevTools throttling, which is quite different from the two other approaches that I mentioned. It is very simple. All it really is a minimum request duration. It doesn't have any concept of server connections or round trips or content encoding, all of those things. So if you look at the connection here, it's still really fast. Nothing has changed. And all it really does, it holds back the data until the amount of latency that has been specified, in this case 2 seconds, has passed. So that is one limitation of it. And the second is it has no concept of resource priorities. So if you start loading data, it will all kind of come intermingled rather than in right order. So this is an example of a website. It's kind of main image, kind of, it's discovered really early on, and it is very important. But actually, Chrome is also kind of downloading all the other resources at the same time. So that kind of slows down the main image. And this is an example from that, where with DevTools throttling, testing one page, it takes about 30 seconds for the largest contentful paint. But if you use packet level throttling, which kind of preserves the kind of accurate priorities, it just takes about 10 seconds. So DevTools is fine for kind of basic performance testing, but it has its own kind of set of limitations. And basically, this was added 10, 15 years ago, and it's not perfect, but it's kind of been working OK. But basically, this March, there was a proposal to kind of redo kind of DevTools throttling and try to improve it. So there's all these issues right now where it doesn't really understand the network. And basically, the idea is to kind of create a new kind of network level way to kind of measure, to delay the network and kind of make DevTools throttling more accurate. In the meantime, we have a free tool that you can use on debugbear.com/test. You can also get off money. We have a performance monitoring tool with real user data and synthetic tests. And yeah, that's all from me.